NASA's spacecraft has sent warning signals to Earth again for nearly 5 decades. The spectacular Voyager space probes have
So how can sound escape when even light itself cannot escape? What you're actually listening to is vibrations.
Shocking in the last 2 decades. NASA has officially disclosed that the Voyagers encountered an unknown force within the vast expanse.
You got to hang on that object to get those data.
What did the Voyagers find, and what prevented the spacecraft from transmitting this discovery immediately? Let's find out. If we make contact with them, I think in this century we'll probably pick up signals from an extraterrestrial civilization. NASA's twin Voyager spacecraft have transformed into 2 incredible time capsules representing their era. These remarkable man-made space probes have boldly ventured beyond our solar system, charting new territories and delivering groundbreaking discoveries to scientists on Earth. What most people don't know is that these spacecrafts have a memory capacity that is 3 million times smaller than a regular smartphone and transmit data at a rate approximately 38,000 times slower than a 5G internet connection. Still, these spacecrafts, designed in the 1970s, are some of the most successful probes ever launched. In an unexpected turn of events, the Voyagers have made a recent discovery that has divided the scientific community, with many scientists hoping that the data is a result of a malfunction rather than genuine readings. The strangest part of this incident was that it appeared like the probes had to conquer an extraterrestrial force to deliver this message to Earth. Before we delve into NASA's latest findings on this incident, let's take a closer look at these spectacular probes that have tirelessly observed the cosmos on behalf of our planet. These 2 spectacular spaceships owe their launch to a rare celestial alignment, which takes place once every 176 years. In this specific instance, the 4 largest planets in our solar system played the role of the guiding stars. These planets, Jupiter, Saturn, Uranus, and Neptune, created a cosmic gravitational slingshot effect that could boost a spacecraft's speed as it passed each giant planet. It was as if the spacecraft were being tugged along by an invisible celestial rope, propelling it forward with a burst of momentum. However, this alignment presented a major limitation. It took place only once in nearly 2 centuries. This rare alignment offered a golden opportunity for interplanetary exploration. To take full advantage of this celestial event, a spacecraft had to be launched in the mid-1970s to reach these distant planets while the planetary lineup was still in effect. NASA seized this once-in-a-lifetime chance and created 2 identical spacecraft to embark on this epic journey. In a captivating display of cosmic exploration, Voyager embarked on its remarkable journey from Cape Canaveral, Florida, on August 20th, 1977. Voyager 2 was launched into space propelled by the Titan III Centaur rocket on September 5th, 1977. Voyager 1 followed suit, embarking on a twin odyssey into the cosmos. Their primary mission was to explore the gas giants of our solar system, Jupiter and Saturn, along with the moons that encircle them. Yet, these intrepid explorers far surpassed their initial objectives, embarking on a voyage that would carry them to the outermost regions of our celestial neighborhood. Voyager 1 and Voyager 2 have achieved numerous milestones during their epic journey. They've endured longer than any other spacecraft in history and ventured farther from Earth than any other human-made objects. In fact, they've crossed the threshold into interstellar space, making them the first human-created objects to achieve this feat. Their voyage into interstellar space, beyond the Sun's sphere of influence and into the uncharted expanse of the galaxy, has yielded invaluable data, leaving scientists astounded. As pioneering interstellar probes over 12 billion miles from Earth, they continue to surprise physicists with their discoveries. One such astonishing discovery is the recent warning from the space probes, confirmed by NASA scientists. We'll delve into that in detail shortly. The Voyagers stand out as extraordinary space probes due to their utilization of self-powered radioisotope thermoelectric generators, RTGs. These nuclear batteries, also referred to as radioisotope power systems, employ the Seebeck effect to convert heat from decaying plutonium into electricity. Remarkably, these RTGs operate without any moving parts, minimizing the risk of wear and tear and making them exceptionally well-suited for harsh and remote environments. One notable advantage is that these generators are not dependent on solar energy, making them highly advantageous for deep space missions. However, there's a catch. As time progresses, the decaying plutonium in the RTGs gradually reduces their power output. Despite this, the overall mission has not been compromised, thanks to the proactive measures taken by NASA engineers. They have strategically deactivated heaters and non-essential systems that do not impact the spacecraft's flight capabilities in order to compensate for the diminishing power supply. But the engineers' efforts don't end there. The Voyager spacecraft was designed to use a special 8-track tape system for data storage and playback. Here's how it works. First, the scientific instruments on board the Voyager probes collect various types of data, such as images, audio recordings, and measurements, and convert them into a digital format. The digital data is then serialized and stored on the 8-track tapes, which feature 8 parallel tracks for efficient storage. When it's time to transmit the data back to Earth, the onboard computer sequentially reads the data from the relevant tracks. The read data is transmitted through the spacecraft's communication system, primarily utilizing its high-gain antenna to send the information back to Earth. On Earth, receiving stations capture and decode the transmitted data, preparing it for scientific analysis. The materials used in these tapes are specially designed to withstand the rigors of space. They typically comprise a metallic base layer made of materials like stainless steel, which is resistant to radiation, extreme temperatures, and the vacuum of space. Each track on the tape is coated with a magnetic material that stores the digital data, designed to resist degradation over time. The tapes are also encased in protective enclosures to shield them from potential damage sources like micrometeoroid impacts. The enduring functionality of these tapes is remarkable. Regardless of their old-fashioned design, they continue to operate and transmit data back to Earth every day. What are the notable achievements of the Voyager spacecraft? The achievements of the Voyager twin probes have been nothing short of spectacular. Their early observations of Jupiter and Saturn's moons, made over 40 years ago, astonished researchers and shattered previous assumptions about these distant worlds. These moons, once thought to be as inert and heavily cratered as our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, reached several significant milestones during its journey. As these spacecraft continue their remarkable voyage, NASA has implemented a series of measures to extend their operational lifespans. Over the past 3 years, non-essential components and heaters have been turned off to conserve energy, enabling them to operate well into the next decade, with an estimated mission end date of 2030. For the scientists and engineers who have been part of this extraordinary journey since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work have seen the project through far beyond their initial expectations. The data returned by the Voyagers has provided invaluable insights, fueled countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were not just ordinary spacecraft. They were meticulously designed to be stable platforms with a rotation rate more than 15 times slower than the hour hand of a clock. This design minimized any visual blur as the spacecraft captured images and data while hurtling through space. Their impressive imaging capabilities began to astound scientists and the public even before their encounters with the outer planets. The spacecraft started transmitting images of Jupiter while still several months away from the planet. These early images, revealing the gas giant's swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly set the stage for the Voyager's groundbreaking observations. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in the solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. These images revealed towering volcanic plumes and a surface marked by the ejection of volcanic material. Pele, one of Io's most prominent volcanoes, has erupted 30 times higher than Mount Everest, covering an area nearly the size of France. The Voyager spacecraft captured over 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the incredible diversity of moonscapes in the Jovian system. Before the recent warning signals, the twin Voyagers have been making spectacular discoveries since their launch. One of the most surprising findings was the existence of Jupiter's rings. These rings, though faint, were a revelation and added to the intrigue of the gas giant. Additionally, Voyager 2 revealed that Europa, one of Jupiter's 53 named moons, possessed an icy shell believed to be over 60 miles thick. These findings challenged previous assumptions about the nature of these distant celestial bodies and inspired further investigations into the potential habitability of icy moons. As the Voyagers departed from Jupiter, they received a gravity assist that provided them with a farewell kick, propelling them towards Saturn. Without this vital boost, they would have been unable to escape the sun's gravitational pull and venture further into space. Voyager 1 and Voyager 2 soon went their separate ways, each heading towards new frontiers. Voyager 1's path took it close to Saturn's moon Titan, which is cloaked in an orange hazy atmosphere. This moon's mysteries piqued scientists' interest, leading to further studies of its complex chemistry. Voyager 1 then turned northward, departing from the plane of the planets, and began its journey beyond the realm of our solar system. Voyager 2, on the other hand, embarked on a series of adventures that brought it to the outermost planets of the solar system. In 1986, it made a historic flyby of Uranus, where it discovered 10 previously unknown moons, increasing the planet's moon count. 3 years later, Voyager 2 reached Neptune, revealing the remarkable features of this distant ice giant. During its encounter with Neptune, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, making it the fastest wind ever recorded on a planet in our solar system. As the spacecraft passed within 2,980 miles of Neptune's azure methane-rich atmosphere, it provided unprecedented insights into this distant world. Triton, Neptune's largest moon, was found to be one of the coldest places in the solar system, with surface temperatures plummeting to minus 391 degrees Fahrenheit. Triton also exhibited unique features, including ice volcanoes that ejected nitrogen gas and icy particles 5 miles into its thin atmosphere. These discoveries expanded our understanding of the variety and complexity of celestial bodies in our solar system, even in the outermost regions. One individual who played a pivotal role in extending the missions beyond their initial goals was the renowned astronomer Carl Sagan. As a member of the Voyager mission's imaging team, he passionately advocated for capturing one last set of images before the cameras on both spacecraft were turned off. These images would offer a parting gift to humanity, a final glimpse of our home planet from the distant depths of space. Sagan's persistence paid off. On Valentine's Day in 1990, Voyager 1 turned its camera back toward the inner solar system and captured a series of 60 images. The most iconic among them, known as the pale blue, remains an unforgettable symbol of our place in the cosmos. Taken from a distance of 3.7 billion miles, it is the farthest image of our planet ever recorded. Earth appears as a tiny pale blue speck, barely distinguishable in the vastness of space. Was there a recent malfunction? And how is it connected to aliens? NASA's Voyager spacecraft has revealed startling new insights into the profound emptiness of interstellar space. According to NASA, cosmic rays are 3 times more intense beyond the heliopause, the protective shield encasing our solar system, compared to its interior. But there's more to the story. Scientists have combined the findings from the Voyager mission with data gathered in later missions, unearthing an eerie humming sound captured by Voyager 1. This strange resonance appears to be linked to mysterious waves detected in tiny amounts of gas existing in the nearly inhospitable interstellar space. This theory is not unanimously accepted as the source of these bizarre sounds. There is a large group of science enthusiasts who are of the opinion that it's caused by extraterrestrial creatures. That sounds absurd, right? But in a moment, we will back to why that might be a compelling argument. For over 45 years, the Voyager missions have embarked on a quest to unravel the mysteries of our solar system. However, the revelations they've brought forth have proven more spine-chilling than anyone could have fathomed. Scientists have now come to realize that the heliopause, the boundary that separates the heliosphere from interstellar space, is not a static line. It's a dynamic, shifting obstruction that constantly changes shape. This strange activity has left experts both baffled and apprehensive about the future. Moreover, the Voyager spacecraft has accumulated invaluable data on the Sun and its influence on our solar system, granting insights into how this colossal celestial body exerts its control. Yet, what's most unsettling is that the Voyagers have continued to function in temperatures far below their design limits, defying our conventional understanding of how technology should operate. As scientists merge Voyager data with information from other missions, they are beginning to construct models predicting how the heliopause will transform in the future. However, the unpredictable and uncontrollable nature of these forces makes it impossible to discern what lies beyond the boundary of our solar system. Could we encounter hostile forces or face unknown perils? Only time will unveil the answers. Recent research on the heliopause has yielded perplexing data, leaving scientists both bewildered and awestruck. In 2014, the Interstellar Boundary Explorer, IBEX, observed the brightening of energetic neutral atoms, ENAs, revealing asymmetries in the heliopause that defied earlier models. Even more astonishingly, an analysis of data from Voyager 1 and Voyager 2 disclosed significant changes in the heliopause over a relatively short period. This phenomenon, referred to as entry speaking, has left scientists eager to continue studying the heliopause. However, the most astounding revelation came in May of last year when the Attitude Articulation and Control System, ACS, on Voyager 1 began transmitting